In this video, we're going to go over the Work On It activity on page 120 and 121. This is going to be similar to one of our earlier Work On It experiments, but we're going to kind of go to the next step with this one. In this investigation, you're going to build series and parallel circuits. Follow the procedure to complete the investigation. Collect your data by recording what you see and answering questions that are asked. So this time we're going to go actually step by step through it. Okay, procedure number 1. Connect one end of the wire to the end of the battery. Connect the other end of the wire to the light bulb holder. So once again, I don't have the LED and light bulb holders like in the experiment, so I'm using old flashlight parts. 3, use a second wire, attach one end to the other side of the light bulb holder. I've already done this in advance. And 4, attach the free end of this wire to the battery. If the light bulb goes on, you have a series circuit. Draw the circuit diagram with the proper symbols you learned in lesson 8. Okay. Disconnect one of the wires from the battery. What happens to the light bulb? It goes off. Okay, so now we're going to connect that free end to another light bulb. Just going to scroll down on my computer here so I'm following the steps properly. Using the third wire, attach one end to the other side of the light bulb and connect it to the battery. So just like before, we have the two lights going. We have completed a series circuit. So for step 8, it says unscrew one of the light bulbs. So just like our last Work On It program, I'm going to substitute a different light for it, which has a bulb L. Okay. Okay, the wires are properly connected. You can see that in this series circuit, the series is broken because of the missing light bulb, so we have no light going through. And that last step is unhook all of the materials. So in the second part of this Work On It, we're going to create a parallel circuit. Now a parallel circuit, if it's done up properly, is going to alleviate lighting problems when you do have a bulb out. Okay, so there's a few more wires involved in this one. I'm just going to disconnect this one, disconnect this. Okay. So I'm going to take step 1, connect one end of a wire to one end of the battery. Step 2, at the free end of the wire, connect the ends of 2 other wires. Sorry, all these wires are quite stiff. It's quite cold in the garage today. Okay. Step 3, connect 2 light bulbs, one to each of the 2 wires. Oops. Okay, and step 5, make a 3-way connection by joining the 2 free wires to a third wire as in step 2. Complete the circuit as shown in the illustration. Draw the circuit diagram using the proper symbols. So I'm going to do that now. Okay, I'm going to hook up the negative on the first light. have power going to that one. And now I'm going to hook up the negative for the second light. And I have power to both of them. Okay. Now, step 6, unscrew one of the light bulbs in this circuit. Write down what happens. So just like before, I'm going to have to substitute the lights. Okay, so I have the second one hooked up with the light out. Now, this light is on, so in a parallel circuit, if one bulb's out, it won't affect the other ones. Unlike the series circuit, if it was set up like that, this one would be out because that one is out. Step 7, unhook all of the materials. Okay, so in your house, everything for your lighting and that, all of your plug-ins are all set up on parallel circuits. If your house wasn't set up that way, if you had one light bulb out in a lamp, you would lose the power to everything in your house because the circuit would be broken. So that's why they use parallel instead of series circuits in homes.